Hi, I'm Don Milton, professor of occupational environmental health in the University of Maryland School of Public Health. And today I'm here with my colleague Jelena Srebric, who's a professor of mechanical engineering in the Clark School of Engineering here at the University of Maryland. So thank you for joining me today. And Dr. Srebric, I know you and I have known each other for a couple of decades by now, but please tell us a little bit about yourself and how you got interested in this topic.
Okay, so I would say thank you, Don, for having me here for this discussion between engineers and public health scientists. We enjoy the privilege of working together for quite some time. And I would say that some origins of my interest, of course, are always personal. And a lot of people where I come from suffer from respiratory health issues. Solutions to those problems are not easy, but realizing that engineering solutions are possible made an exciting career for me. And one of the problems that kind of highlight all of this issue is that you can know as much as you want, but if you are showing up in public spaces, exposure or experience with germs is unavoidable. So I'm glad to be here today and we can start our discussion on specific topics.
So you and I are sitting here together. We're breathing the air in this room. Um, so if I had the flu right now, how's that affect you?
It certainly affects me. And you're asking me about the question on invisible life of germs. We all have this experience of meeting each other's, greeting each other's, talking, and what is happening is that our breath is coming like you would have experience or maybe visual image of smoke coming off a tailpipe. So as I'm talking, my breath can basically move around. And if I'm directly facing you and we're close enough, you definitely get exposed to my breath. So that's the way we can affect each other's if we have influenza.
So how does the breath go in the air? Does it like rapidly disperse or does it like hang together? What's it like?
That is a great question. I have this image of a bubble just blowing and then bursting, all right? And we call these bubbles that are coming with exhale breath, and then they stop and burst once you are inhaling. So we call them plumes, technically, and they are present in everybody's breath. Just if you happen to have influenza, you have more than air just floating around. You have these germs that are floating around with your breath.
So this is like being near somebody who's smoking and you can smell it and you can see the cloud is so concentrated close to them. You can see it.
Correct.
But then farther away, it's hard to see.
Correct. It's hard to see because the concentration goes down and that cloud is less potent the further away you are.
Okay. So what can you do to reduce the concentration, how much exposure you get?
So I would say like with any cloud, right, a little wind can help. So if you have issues with the clouds, blowing some air around the cloud or at the cloud can help. So an example of that would be even mechanical ventilation or opening your windows would certainly help to disperse the clouds of germs or basically your exhale breath.
So are we talking about like just getting them out of the room, or are we talking about like even if it's slowly leaving the room, am I better off if I'm not getting a concentrated dose right close to you?
You just answered your question. Definitely. It's much better to be exposed to a smaller dose of germs than to a larger one. And basically, it's easy to imagine that with a smoke concentration. But with germs, we tend to be very nonchalant because we don't see them. And we don't see that concentration coming our way. So that's where it's really tricky to understand and appreciate what is happening with this transmission in the air.
So how would a fan in the room impact all of this?
So again, you can imagine these clouds that we discussed, or a smoke of cigarette. That stuff would be just blown away and mixed to the point that at certain level becomes non-harmful to you personally.
So if we have UV in here, what difference does whether you've got some mixing going on have to do with how well the UV works if we're using upper room UV?
Sure. Great question. In principle, UV can help in two ways. One way is basically for a special kind of UV that is 222 nanometers that can be present in the environment when you and me talking. That kind of UV could even affect and reduce the concentration in a cloud before it arrives to your face. The other way it does help is the other type of UV 254 nanometers. That kind of UV could disinfect the air or those clouds as long as the clouds are being seen by my UV or germs are being seen by my UV.
So if we have the longer length germicidal UV where it needs to be in the upper room because you don't want to get it in your eyes, it'll cause eye irritation, then you're saying if there's a fan mixing the air, it'll help take the germs up and get them zapped.
Correct. The germs need to be put in the path of UV, whether it's the shorter wavelength, which can be between you and me, or this longer wavelength, which is in the upper room. Then you have to basically bring germs to the UV light. And one thing that we have discovered in our study is that germs have to spend enough time in that light in order to be affected. And therefore, when we talk about fins and mixing, you would think now, because we talked about clouds, that it's very important to just blast the clouds with as much air as you can. But that's not the case. So we have found in our study that it's much better to have not low, not very high, but some medium fan rotation that would be sufficient to break the clouds, but also to bring the germs to the UV light and let the germs spend enough time in the UV field in order to be inactivated.
So in the experiment that I was involved with back 20 years ago, we were fortunate to have actually used medium speed on the fan, where we found that I think we were getting 5 or 10 times as much effectiveness, killing of germs with the fan than just with the heat from simulated people being in the room. And your models show the same thing.
Absolutely. So that medium fan velocity allows you to reap the best of both worlds. You can dismember the clouds, am I right? Or basically reduce the organization in the clouds, and then also bring the germs to sufficient amount of light that they need.
So that was with upper room UV. But what about far UV? Why would the mixing make a big difference there? Do we know?
We are not certain about that stuff. We know without UV, just mixing the air would definitely help reduce risk to any occupants in the room. For far UV, we certainly believe that's the case, but it still remains to be thoroughly investigated.
All right. Well, thank you very much for coming in this afternoon, and I hope you found this a useful little video.
Thank you, everybody.